Very good morning to all of you. This is Professor Priya Yadav from Civil Engineering Department, SIRT, Sage University, Indore. Today, I'm giving a presentation on structural health monitoring. The contents are introduction, objectives of structural health monitoring, types of structural health monitoring, system components of structural health monitoring, steps used in structural health monitoring, sensors in structural health monitoring, and last topic is importance of structural health monitoring. Introduction. Structural health monitoring refers to the process of implementing a demand detection and characterization strategy for engineering structures. Structural health monitoring involves the observation and analysis of a structural system over a time using periodically sampled response measurement to monitor changes to the material and geometrical property of the structures. Damage. Before knowing the structural health monitoring, we have to know that what is damage. Damage is the changes to the material or geometrical properties of a structure system, including changes to the boundary conditions, system connectivity, which adversely affect the performance of the structures. This is the image of a structure in which damage occurs. Objectives of structural health monitoring. Performance enhancement of an existing structure. Second is monitoring of a structure affected by the external factors. Third is assessment of post-earthquake structural integrity. Fourth is decline in construction and growth in maintenance needs. Fifth is move toward the performance-based design philosophy. Types of structural health monitoring. There are two types of structural health monitoring. First is short-term structural health monitoring and second one is long-term structural health monitoring. Short-term structural health monitoring. It consists of live load and dynamic testing. Data is collected over a relatively short period of time when the field tests are taking place. The collective measurement can provide information about the structural performance, such as load, moment distribution, stress strain levels, serviceability requirements, and so on. Long-term structural health monitoring. For long-term structural health monitoring, the output of this process is periodically updated information regarding the ability of the structure. Long-term monitoring usually consists of collecting vibrations, environmental data to evaluate the structural condition over a long period of time. With long-term monitoring, changes in structural behavior can be detected without human interaction or environmental effects. Commonly monitored responses parameters include mechanical response. It includes load, deformation, strain, acceleration, and cracks. Physical responses include temperature, humidity, pore pressure, wind speed, and so on. Chemical response include chloride penetration, sulfate penetration, pH value, steel oxidation, and carbonation. System component of structural health monitoring. The system component of SHM can be depend upon the structure to be monitored and information to be collected. However, a modern structural health monitoring system include the following components. First is structure, second is sensor system, third is data transfer, fourth is data processing system, fifth is storage of data and data diagnostics. This is the structural health monitoring system component image, in which first structure which have to be monitored. We use various type of sensors here, DS system on site, and this is the communication system. This is the data processing system by using a computer system, which is it is done automatically. Then data storage, data retrievals, and data diagnostics. Structure. The critical structure like bridges, tunnel, dams, and wind turbines are mostly monitored as they are vital part of the national infrastructure. Sensor system. There are several sensors which is used in structural health monitoring. We have to proper knowledge about the sensors and how to activate the sensors and techniques to save the data. The placement of sensors should not alter the behavior of the structure. This can be achieved by considering the placement of wiring, boxing, and so on. Data transfer. The data transfer can be done through the wire, which is commonly and cost effective but not be practical for large structures. Alternatively, wireless communication can be considered, which is suitable for large structure, but it is slower and more expensive than the wire method. Fourth is digital processing. After the data is transferred, the digital processing is carried out to eliminate the unwanted effects such as the noise. It should be carried out before the information is stored. Digital processing will make the interpretation of data easier, faster, and more accurate. Fifth is data storage. The processed data can be stored for long time and retrieved in the future for analysis of interpretation. Sixth is data diagnostics. Diagnostics process involve the conversion of abstract data to useful information about the structure, condition, and its response to load. So, the final data obtained from structural health monitoring should be detailed and physical, based on which rational or knowledge-based engineering decision can be made. These are the steps of structural health monitoring. First step is that determination of damage existence. Second one is determination of damage geometric location. Third one is the qualification of damage severity. Fourth is prediction of remaining life of the structure. Sensor used in structural health monitoring. There are following types of sensor used in structural health monitoring. First is fiber optic sensor, piezoelectric sensor, vibrating wire transducers, shape memory alloys, linear variable differential transformer, inclinometer, acoustic emission sensor, and temperature sensor. Measurement of structural response using various sensors. In first column, measurement of structural aspect. In second one, measuring device. First is load. The measuring device is load shape. Second one is acceleration. The measuring device is accelerometer. Third one is wind speed and pressure. The measuring device is anemometer. Fourth one is temperature. The measuring device is thermistor, thermocouples, integrated temperature circuits. Fifth one is strain, and the measuring device is strain gauge. Similarly, sixth one is acoustic emission. The measuring device is microphones. Seventh one is video monitoring. Internet camera and technology are used as a measuring device. Deformation, the measuring device is transducers. The following parameters can be monitored: deflection, strain, rotation, temperature, acceleration, corrosion, pre-stressing force. Importance of SHM, that is structural health monitoring. First is structural health monitoring improves safety and functionality of the structure. Second one is monitor, develop innovative design methodology. Third one is structural condition monitoring and assessment are required for timely and cost-effective maintenance. Fourth one is monitoring scheme help to gather data on the realistic performance of the structure, which in turn will help to design better structure for the future. The source of data, Wikipedia. Thank you so much.